Hey guys, so what we're going to do today is just kind of review proven identities, what we did before the break. I'm going to let y'all do, some of these are going to be homework questions that we did, so we're going to kind of work them and hopefully you can do it. Whatever we don't do, I want you to finish your homework for this. Then tomorrow we will review and then we'll have a quiz. Alright, so I want to prove each identity here. So this is cosine of pi over 2 plus y is equal to a negative sine of y here. Okay, so this is the sum of two angles here. So let's review a little bit. So the sum and difference identities. Okay, so let's start out with cosine. So cosine, we'll call it alpha plus beta here, is going to be cosine of alpha times cosine of beta. It's going to be the opposite sign, so then it'll be minus sine of alpha sine of beta. If it was the difference of two angles here, so cosine of alpha minus beta here, so this is going to be the same thing, so it'll be cosine of alpha cosine of beta plus sine of alpha sine of beta. Okay, so your sum and difference for sine, so if it was sine of alpha plus beta, here you're going to have sine of alpha cosine of beta. It is going to be that plus sign right there, so it's going to be plus, and then it'll be sine of beta cosine of alpha. And then if it was sine of alpha minus beta, it's going to be sine of alpha cosine of beta minus sine of beta cosine of alpha. The double angle, so the double angle for sine, so if it was sine of 2 times alpha, then it would be 2 times sine of alpha times cosine of alpha. Double angle for cosine, it could be written a few different ways, but one of the crazy ones, cosine squared alpha minus sine squared alpha. And then we could use the Pythagorean identity to rearrange these. So it can also be 2 cosine squared alpha minus 1, or it could be 1 minus 2 sine squared alpha. Okay. All right, so let's do this one though. Well, put this over here. All right, so if I wanted to prove this one, this is cosine of two angles added together. So this would be cosine of pi over 2 times cosine of y minus sine of pi over 2 sine of y. So cosine of pi over 2 is, from the unit circle, is 0. So basically 0 times cosine of y is 0. And then sine of pi over 2 is a 1. So this will be a negative sine y. And that's what we are looking for. So there we go. We showed that that one is true. All right, this one's number 3 in your homework. So let's prove this one here. It says cotangent of x minus tangent of x is equal to cosine of 2x over sine of x times cosine of x. So we always want to take the harder side and put it together. That's me. You could also change these two and then try to put them together. However you want to work through it. But cosine of your double angle is what? Cosine squared minus sine squared. So cosine of your double angle, so it'll be cosine squared x minus sine squared x. And I've got a minus sign right there, so I then can expand these. So I have two things over on the side. I have one over here. So if I wrote cosine squared over this, sine squared over this, then I could get, maybe reduce it a little bit. So it'll be cosine squared x over sine x times cosine x. And then here we've got sine squared x over sine x cosine x. So cosine squared, so one of your cosines goes away, one of your sines goes away. So I'm going to be left with cosine over sine minus, this one is going to be sine over cosine. So cosine over sine is cotangent. Sine over cosine is tangent. And that's what we're looking for. All right, let's look at 5 here. Okay, so here we want to simplify this. This is sine of theta over 1 plus cosine of 2 theta. Okay, I want to show that that's equal to tangent over 2 cosine theta. So that means cosine plus cosine, basically. Okay. So if I wanted to simplify this a little bit, we could change this cosine of our double angle right here. That's the only thing that we really can change, that we know of something. So cosine of our double angle, if we look over here, this is 2 cosine of theta. So how can I change cosine of a double angle into 2 cosine? 2 cosine here. Something, maybe that looks like that. So maybe this one here, it's got a cosine squared. It's not there yet, but maybe I could get it there a little bit. So I could rearrange this and write this as 2 cosine squared theta minus a 1. And then what happens right here with your 1s, they're going to go away. So you're going to be left with sine of theta over 2 cosine squared theta. Well, cosine squared theta is just 2 times cosine theta. Well then, what is sine over cosine? Sine over cosine is just tangent, so this will be tangent of theta over 2 cosine of theta. And that's what we were looking for. All right, let's do one more. so we've got sine of x plus y minus sine of x minus y over cosine of x plus y plus cosine of x minus y. Well, I'm going to show that that equals tangent of y. So there's nothing much I can do with tangent, but I can expand both of these and both of these. So sine of x plus y is going to be sine of x times cosine of y plus sine of y cosine of x. And then same thing here, but you will have a minus sign. And then cosine here of x plus y, so that's going to be cosine of x, cosine of y, minus sine of x, sine of y. And then this one will be cosine of x, cosine of y, minus sine of x, whoops, that should be a plus, sine of x, sine of y. Alright, so when the minus sign gets distributed, right here, this turns into a plus sign. So here what happens, your sine of x, y, sine x, and cosine of y, those are going to go away. Here you're going to be left with 2 sine y cosine of x's. And then in the denominator here you'll have 2 cosine x cosine y. And then your sine x's and your sine y's goes away here. Alright, here your cosine x's are going to go away and your 2's are going to go away, so you're going to be left with sine y over cosine y. And sine y over cosine y is the beautiful tangent of y. Okay? Alright. So I want you to finish up your homework. If you didn't do it already, finish that up. Tomorrow we will review and we'll get ready for your quiz so that you will be prepared. If you have any questions, let me know. Y'all have a good day.